Well, this is a neat 2020 question. The problem is time intervals of a given clock of the readings is given for you, uh, measured by a clock. Time intervals of measured by a clock. Different readings measured by a clock is given for you. What is the percentage relative error of these observations? So let's first try to find out what is our aim is, what we are trying to find out, what we are supposed to find out in this problem. We have to find out the percentage of relative error. So the percentage of a relative error can be found using the average of the errors by the average of the original reading, that is a relative error. You multiply with 100, you will get a percentage. So what I need to know, what I need to solve in this problem is I have to solve two things, right? Average of time intervals is how much. Next one is average of error in time intervals. Delta t is how much, right? So let's first find out the average of the all the times that are available for you. 1, 2, 3, 4, 5 readings are available for you. So the average of the time intervals t is average of all these readings: 1.25, 1.24, 1.21, 1.28. Of course, 1.27 is also there after 2, 4. I have missed that. How many? 1, 2, 3, 4, 5 readings are there. By the total number of the readings gives the average of that. If you observe these readings little carefully, 1.25 as a figure of consideration. This is 1.24. It is less by 0.01. It is less by 0.04 when compared with 1.25. It is more by 0.03. It is more by 0.02. It is more by 0.02. It is more by 0.03 plus. It is less by 0.04. It is less by 0.01. This is the reference itself. So, if you observe closely, carefully, what they are less is 0.04 and 0.01, that is 0.05. What they are more is 0.03 and 0.02, that is 0.05. This is the same. So, what is this plus is compensated with the minus. So, I will get an average of that 1.25 itself. If you calculate, I will get an average of that 1.25 second. I got, see the average of the time intervals, but I want to know the errors, right? So what is error? How do you find delta t? Delta t could be found as modulus of the average of time minus each of time interval, that whatever is there for you. So what is delta t average? So if I have to find out the average of delta t is plus for the second reading plus for the third reading and so on, divided by, there are 5 readings. 5. So what will be the delta t value if I have to calculate? Modulus of 1.25 minus average is 1.25, that is 0.00 itself, right? The second one is 1.24 minus 1.25 under modulus, that is 0.01, right? The third one is 1.21 minus 1.25 under modulus, that is 0.04. The fourth one is 1.28 minus 1.25, that is 0.03. Next one is 1.27 minus 1.25, that is 1.02 divided by 5. So 0.05 0.08 and 0.02. That's equal to approximate automatically. If I add all of them, 0.1 by 5, that is 0.02 second. Now I got delta t, I got t, therefore I can easily calculate the percentage of relative error. Percentage of relative error is average of the errors by the average of the reading. As you want percentage, multiplied by 100. Average of the errors is 0.02. Average of the reading is 1.25 multiplied by 100. That is 2 by 125 into 100. That is 24 fives and 24 fours and 25 fives. That's nothing but equal to 8 by 5. That is equal to approximately. That's equal to approximately. Obviously, 1.6. So the percentage of the absolute error in that case is 1.6. That's how we solve this problem. So I want you to remember few things while you are solving the problem. That is the core formula. Percentage of the relative error is average of the errors by average of the readings multiplied by 100. So simple to find out the average. Of course, average of the errors here. How do you got these values? Each of these values, if you look carefully, this is average of the time 1.25 minus each of the reading. First reading is 1.25 itself. That's why you got a 0 here. Look at the second one. Second is modulus of 1.24 minus average 1.25. You get, of course, a minus of 0.01, but we have a modulus like that. You will get all of these values, and then you will get an answer of 1.6%. That's how we solve the problem. Thank you for watching.